I'm about to show y'all how tides work on a flat earth. Now, we were taught that the gravitational pull from the sun and moon create the high and low tides. If this was the case, we would see centripetal force from the ISS. It would literally look like this from the ISS. Now, the sun, being the greater light, creates an electromagnetic field.
Light is energy, and depending on the type of light, we have a variation in the size of the wavelength. Light is a wave of vibrating magnetic and electric fields. There are many kinds of light, and each one has a longer or shorter wavelength. Light is just one part of a larger group that is called the electromagnetic fields. The visible light, which humans can see with their eyes, is part of the electromagnetic field.
Now, water is diamagnetic. Water is something that repels a magnetic field. Here's an experiment of diamagnetism.
Is water A, attracted by a magnet, B, repelled by a magnet, or C, completely non-magnetic? Most of you will answer C, and you wouldn't be wrong. After all, in everyday life, you notice nothing unusual about water and magnetism. But interestingly enough, the correct answer is B. Water is actually slightly repelled by a magnet. This anti-magnetic property is called diamagnetism. However, the effect is extremely weak. That's why most people don't know it's there. To see it, we need to build an extremely sensitive detector. Luckily, this is brutally simple. Just get a basin of water and put into it a styrofoam block. It's going to move around a lot, but this is actually a good thing. The styrofoam floats, and because it's so light, even the smallest force will push it around. So try and build this away from drafts and moving air, and be careful that your own breathing doesn't disrupt it. The water helps to dampen any stray motion. Now get a test tube and fill it with water and push it into the center of the styrofoam. This is the water we're actually going to measure, not the water in the basin. Now steady it, and when it's still, get a strong neodymium magnet and hold it as close as possible to the tube without touching it. Oops, I hit it there. Let me steady it. Okay, let me try again. Slowly but surely, it's moving away from the magnet. It's an extremely weak effect, but it's happening.
So this is how the tides work. I believe that the sun and the moon act as a battery in the sky. The sun, also known as the greater light, is a positive charge, and the moon, which is a lesser light, is a negative charge. The sun's positive charge affects the water at high tide, and the moon's negative charge affects the water at low tide. The opposing forces of the sun and moon causes the ocean to be in a constant state of diamagnetism. And this is why a constant rate of waves are always being thrown at the shore. It's really that simple.